Hygroscopy is the ability of a substance to attract and hold water molecules from the surrounding environment. This is achieved through either absorption or adsorption, with the absorbing or adsorbing substance becoming physically changed somewhat. This could be by an increase in volume, boiling point, viscosity, or other physical characteristic and properties of the substance. As water molecules can become suspended between the substance's molecules in the process. Hygroscopic substances include cellulose fibers, sugar, caramel, honey, glycerol, ethanol, methanol, diesel fuel, sulfuric acid, many fertilizer chemicals, many salts, and a wide variety of other substances. Zinc chloride and calcium chloride, as well as potassium hydroxide and sodium hydroxide, are so hygroscopic that they readily dissolve in the water they absorb. This property is called deliquescence. Not only is sulfuric acid hygroscopic in concentrated form, but its solutions are hygroscopic down to concentrations of 10 volume% or below. A hygroscopic material will tend to become damp and cakey when exposed to moist air. Because of their affinity for atmospheric moisture, hygroscopic materials might require storage in sealed containers. When added to foods or other materials for the express purpose of maintaining moisture content, such substances are known as humectants. Materials and compounds exhibit different hygroscopic properties, and this difference can lead to detrimental effects, such as stress concentration in composite materials. The amount of a particular material or compound is affected by ambient moisture and may be considered its coefficient of hygroscopic expansion or coefficient of hygroscopic contraction, the difference between the two terms being a difference in sign convention. Differences in hygroscopy can be observed in plastic laminated paperback book covers. Often, in a suddenly moist environment, the book cover will curl away from the rest of the book. The unlaminated side of the cover absorbs more moisture than the laminated side and increases in area, causing a stress that curls the cover toward the laminated side. This is similar to the function of a thermostat's bimetallic strip. Inexpensive dial-type hygrometers make use of this principle using a coiled strip. While some similar forces are at work here, it is different from capillary attraction, a process where glass or other solid substances attract water, but are not changed in the process. The similar-sounding but unrelated word hydroscopic is sometimes used in error for hygroscopic. A hydroscope is an optical device used for making observations deep underwater. Engineering properties. The amount of moisture held by hygroscopic materials is usually proportional to the relative humidity. Tables containing this information can be found in many engineering handbooks and is also available from suppliers of various materials and chemicals. Hygroscopy also plays an important role in the engineering of plastic materials. Some plastics are hygroscopic while others are not. Biology. The seeds of some grasses have hygroscopic extensions that bend with changes in humidity, enabling them to disperse over the ground. An example is needle and thread, Hesperos dipicamata. Each seed has an awn that twists several turns when the seed is released. Increased moisture causes it to untwist, and, upon drying, to twist again, thereby drilling the seed into the ground. Thorny dragons collect moisture in the dry desert via nighttime condensation of dew that forms on their skin and is channeled to their mouths in hygroscopic grooves between the spines of their skin. Water also collects in these grooves when it rains. Capillary action allows the lizard to suck in water from all over its body. Deliquescence. Deliquescent materials are substances that have a strong affinity for moisture and will absorb relatively large amounts of water from the atmosphere, if exposed to it, forming a liquid solution. Deliquescent salts include calcium chloride, magnesium chloride, zinc chloride, potassium carbonate, potassium phosphate, carnallite, ferric ammonium citrate, potassium hydroxide, ferric chloride, and sodium hydroxide. Owing to their very high affinity for water, these substances are often used as desiccants. which is also an application for concentrated sulfuric and phosphoric acids. These compounds are used in the chemical industry to remove the water produced by chemical reactions. Polymers. Many engineering polymers are hygroscopic, including nylon, ABS, polycarbonate, cellulose, and poly. Other polymers, such as polyethylene and polystyrene, do not normally absorb much moisture, but are able to carry significant moisture on their surface when exposed to liquid water. Type 6 nylon can absorb up to 9.5% of its weight in moisture. Applications in baking. The use of different substances' hygroscopic properties in baking are often used to achieve differences in moisture content and, hence, crispiness. Different varieties of sugars are used in different quantities to produce a crunchy, crisp biscuit versus a soft, chewy cake. Sugars such as honey, brown sugar, and molasses are examples of sweeteners used to create more moist, chewy cakes. Etymology and pronunciation. The word hygroscopy uses combining forms of hygro and scopy. It is etymologically interesting because, unlike any other scopy word, it no longer refers to a viewing or imaging mode. It did begin that way, with the word hygroscope referring in the 1790s to measuring devices for humidity level. These hygroscopes used materials, such as certain animal hairs, that appreciably changed shape and size when they became damp. Such materials were then said to be hygroscopic because they were suitable for making a hygroscope. Eventually, though, the word hygroscope ceased to be used for any such instrument in modern usage, but the word hygroscopic lived on, and thus also hygroscopy. Nowadays an instrument for measuring humidity is called a hygrometer.